Welcome, Matt. How are you doing?
Hey,
Hey guys,
hello.
nice to meet y'all.
Yeah,
Glad to
it's
be
such
here.
great. Thank you. Yeah, it's great to have you here. Thank you for coming on and talking about Paul's favorite, and also one of it is near to dear to me, GI Joe. I mean, that's just so cool. Like, so yeah. Can you? Anyway, sorry. Looking at the chat too. What's up, chat? How's it going? Matt, can you tell us a little bit about yourself?
Yeah, definitely. Matt Hilton. I lead the 3D product development for GI Joe. Um, I've been doing it probably about 6, 7 years now. Um, Prior to that, I was actually in the games, working primarily games, so character art, and then kind of made the transition to over to physical product, and been doing this, ever since.
Nice, man. Nice. Well, it's amazing to have you here, and we're really excited about your presentation. So we'll go
Yeah.
ahead and get your screen up right now. Of course, to anybody in the chat, if you guys have questions, please feel free, because myself, Rodolfo, and Daisuke are always looking in the chat for questions, and we'll try to get to as many as we can, obviously given the time. But Matt, why don't you go ahead and take it away?
Sweet. Yeah. Also, definitely shoot out questions. Going to be kind of winging it so we'll be jumping them back and forth from quite a few different things. So feel free to shoot out any questions at any time. But a little additional, I guess, backstory. Um, Starting at Hasbro, I'll pull up some older work. So I was leading the Fortnite line as well. So the Victory Royale, just pulled together a couple of the figures. The line went for probably about 3 or 4 waves, uh, and I had quite a few. These are some of the cool ones. Following that, did the starting lineup figures as well. So that was like your NBA, all this whole lineup here. It was a short run, but it was a fun one. A lot of fun portraits, work like that. And then now I am on GI Joe, so that's the classified line, and then we're also working with the retro card back. Um, so distinction between the two is that the classified design philosophy is a little different. It's kind of more the modern interpretation of these old school figures, whereas the retro card back figures are more they're basically recreations of those old school kind of O-ring figures, but at this different 6-inch higher quality, higher articulation range, the same modern interpretation basically, but the old design aesthetics. And jump right into ZBrush. Don't have a full PowerPoint or anything. We're gonna go. This is the ZBrush Summit, so let's spend a lot of time in ZBrush.
Yeah, it's what the people want, so go for it.
People are here for.
Yep.
All right. So this is that was the cylinder, primitive cylinder. This is just a basic lineup of a couple figures. It's kind of a scale reference, but it helps to kind of show some of the diversity that we're trying to achieve on the classified line. All of these are part of the classified. They're not the retro card backs, but the retros are going to be basically the same thing, just like I said, a different design aesthetic. It encompasses everything from uh, animals to vehicles to all the character lineups. Um, we also have a ton of gear that comes with these guys, which is another aspect of the line. Um, because it's a Hasbro owned IP, luckily we're able to really jam pack all these offerings with a bunch of different material, a bunch of different accessories, and that's a really fun part about the line. Is a lot of times we'll build it to where this web gear will come off, it'll key in, you'll be able to swap it across different figures of similar scales. Obviously, you're not going to be able to. It may not look good putting a, road pigs shoulder pads here on somebody like Pythona, but within reason, we try to make it cross compatible. Um, yeah, and so we have a whole bunch of different stuff in here.
Yeah, that's super cool that, like you were saying, you guys have the IP, so you're able to do a lot more. You're able to really dive in and go nuts with that. And I think that's super cool, especially with this type of lineup.
Oh yeah, absolutely. It's been a lot of fun working on GI Joe because of that freedom. You know, you can take a gun and be like, what would be wouldn't it be cool, if we had the silencer come off or the mag actually come out? And it's like we can split this stuff up into many more parts than you would normally, be able to do. Um, like on a more licensed or on a licensed brand. But they could, they still figure out ways to pull it off, which is awesome too. But it just gives a little bit more freedom, which is always fun. Um, but that's another aspect of it is like all this gear. We kind of want that toyetic aspect to it, which is that playability. What would be fun to play with? Kind of, tapping into your inner child as you're designing this stuff out. Like example is this ridiculous contraption that comes on the heavy duty offering, and I mean it's just literally a bunch of guns that attach to a chassis. Actually, I have one right here where it's well,
Sure.
you can basically kind
I'm
of
gonna
see
try
them.
to make a full
Yeah,
screen. There
right
you
here.
go.
But you can kind of have, all these different like little parts and pieces that, pop off. Um, this kind of has that whole uh,
Yeah.
Avatar-esque construction where it kind of clips in and sits on the character's back. It's got a peg hole or a peg there to plug into a peg hole. All of these swivel up and down. Ammo cartridges, at least in the original design, they did pop off, but we ended up molding a couple of those due to like some costing constraints. But these whole ammo ribbons, we're able to feed that out and feed that through to plug into these weapons. A lot of cool. They were able to pull off a lot of cool like deco on there, um, which is just another word for a paint for those
Yeah.
unfamiliar with the industry term. But yeah, it's a pretty sweet offering. I can jump back in. Yeah. Oh, we got an autosave. Let's cancel that.
Wow. Yeah, that is super intricate. I'm just going to go ahead and ask it because I'm very curious, and I'm as a toy maker myself. What is your favorite articulation piece that you like to model, and do you model those inside of ZBrush?
Um, so favorite two-part question. I would say I really like the animals. Like we have over here, Law and Order offering. It's a German Shepherd. This one was a lot of fun developing because it's a little abnormal. You know, I've cut so many double joints and elbows and knees at this point where it's like I want a different design. I want to design something else, and that's where these animals come in, and they're always a lot of fun. Um, Especially trying to make him highly articulated is kind of a challenge at this scale, especially 6 inches, and then you got a dog that's maybe only 3 inches tall, which then now you're adding additional constraints. Um, and then what was the second part of your question? It was
Yeah, do you model all your articulation pieces in
yeah,
ZBrush?
absolutely.
Heck yeah.
Yep, yep. Yep, the whole process takes. We do the whole thing in ZBrush. So typically, it like starts off with your, traditional high poly sculpt, high density. Everything's kind of, split off into sub tools. But once we get into the engineering phase, that's typically basically a massive Boolean hierarchy that we'll start, sizing things out, chopping like the arms off, and then start working through that chain of just that arm. We'll do that through different Boolean hierarchies. Um, Once it gets to there at a certain point, we're going to send it off to like be tooled in steel because this is all plastic injection molded. um, so at that point, our partners over at the factory will take those engineered files and they'll probably pull it into some sort of CAD software like SolidWorks or something like that to create those inner wells, like hollowing out parts and creating like putting on those final like mushroom caps, little things like that to really get it ready for tooling. But a vast majority of the actual figure development does occur in ZBrush. Yeah.
Nice, nice. I might be this guy. It's okay. You could tell me no. You could be like, Ian, stop asking questions. But like, if there's
No, go
time,
ahead.
maybe if you have time to do a small demo of how you approach joints, that is like a really big question. A lot of artists ask. No one's asked that here. I'm asking because I'm selfishly curious.
Yeah, absolutely. We can build that in for sure.
Okay, cool. And we do have a question from the chat, so I'll let the chat. Are
Okay.
most of the
Yeah.
ligaments, yeah, are most of the ligaments of animals and figures hollow inside? And do you sculpt? And do you sculpt that in ZBrush? You know, is the question.
Ligaments is in like the internal parts.
Yeah, I believe that's where they're going with that.
Yeah, feels like that's
Yeah.
what they were asking. Yeah.
So typically, yeah, like this, for example, is a bunch of different just kind of, I've cut it in a little sloppy in some areas, but it's going to, once it actually gets molded, what they'll most likely end up doing, and what they did on this one is like we'll cut out holes in the underside of this, like the backside, and we'll create like little channels in there because we don't want, you know, if we were to actually mold this, I mean, that's 12 millimeters of plastic thickness that you have in there just from one, you know, measurement. That's not accounting for width as well. So it would be from a plastic weight perspective, it would get pretty hefty. And it's also, any familiarity with like injection molding when plastic it's hot and molten plastic. So when it's molded into there, if you have too much wall thickness, like in this scenario, all of that plastic is going to cool at a different rate. And so you're going to end up with pockets that may, you know, trap air, may create bubbles, it may, you know, dry unevenly. You'll get sink issues where the outside of your sculpt may start to like kind of sink inwards, which is never good because that's fundamentally changing the primary forms. But so yeah, we would end up like coring out a lot of this stuff while maintaining, you know, this engineering that's already cut in there to showcase like this is the desired functionality, and so then we'll go and refine by coring stuff out.
Nice.
Yeah, good question.
Super cool.
Yeah, so I can kind of jump on. There's no more questions on this lineup.
Yeah, no questions yet.
Okay. So kind of just jumping into the general anatomy of a G.I. Joe classified figure. You know, we start off with this kind of a base body sculpt for the latest wetsuit. It's always fun to be able to generate a new base body because that generates new opportunities for potential, you know, reuse later in the line. You know, we might want to paint it differently or change up a couple things, but it creates an opportunity to create some of those tooling standards, like the diameter of you know, certain mushrooms, which is sweet. But this is kind of a clean base body. And then moving on, you know, we have pins, which I've kind of grouped all in here together. And so a typical G.I. Joe classified figure is made up with a double barbell head, a ball joint lower neck, butterflies that are capturing shoulder discs, double discs, you got your wrist discs. We'll sometimes cut those, depending on the character, you might cut those front to back. If they have like kind of more trigger finger type action, like maybe some of your like more like Wild Bill, which is more of like a cowboy-esque type figure, comes with some revolvers, and so we want to get that kind of like double recoil action, or more side to side if you have more like it's usually like handheld swords, things like that, where you want to kind of get those cool poses. And that's really kind of the key, is trying to increase the posability of these figures as much as possible. underneath this PVC, which is just like a soft plastic brief, is kind of like a chassis that we'll use. And then those actually incorporate like hinges in the ball joints on the hips. So those will go up and down as well as rotate on those balls. And so you can actually pull the legs down and fold them up if you want the figure to like sit inside of a vehicle is the main function of that. And then you can also push the hip hinges back up into the body of the figure at a more neutral pose to get a more natural, neutral position that looks, more pleasing on your shelf. And then of course we have, those double knees and then ankle discs.
So we have a question coming in from the chat. Do
Yeah.
you paint your pieces in ZBrush and then you injection mold that poly paint, or do you have a pre-made color scheme set up separately? Like, do you do any painting in ZBrush?
Yeah, so I'm in the sculpting department, so we don't actually do any of the painting of these figures, but our model shop, it will go over to them and they will do a decent amount of, some of them are using mostly ZBrush for that. So they're poly painting, poly grouping. They poly group because I think a lot of them are using like KeyShot to render. And so having those poly groups separates as a material in that render engine, and then they can kind of assign different materials to different parts based on the color breaks. Yeah, a lot of painting does happen in ZBrush. And then that's of course sent over for painting physically, but none of the poly paint ever comes out in final product. It's always kind of just a point of reference for a factory to apply actual paint.
Okay, cool.
So then we also have, our hinges, which is your shoulder hinges. We have an ab crunch, which is technically a hinge. You have your hip hinges, and then we'll also throw ankle hinges on there. So if I was to combine those two, you can kind of see the full breakout of a typical articulation scheme for classified figure. Kind of cool.
Wow, no, that's super cool. One of the questions that just came in too is like a figure like this and its complexity. How long does it usually take you just to complete one figure?
We go through a lot of figures in a year. So at Hasbro, we it's very rapid development cycle, and so at least on GI Joe, we do like, I want to say like close to 70 to 80 figures every year. And yeah, some of those are partial figures, so we'll only be doing a couple new parts, which it makes, it's less work, obviously. But I would say if you were doing a full, complete figure sculpt, that first sculpt of the actual figure, that's going to be ideally 2 to 3 weeks development time just for that initial sculpt, and then another week for cutting the articulation. So you're looking at ideally 4 weeks of development time. And then by the 5th week, we're reviewing with like extended design partners on the design team to be like, what do you think about this? What do we want to change? Blah, blah, blah. And then you're probably looking at another like 2 or 3 weeks of just like going back and forth on, let's change the backpack, let's change the articulation to do this, what have you. So in all, 5 to 8 weeks, ideal, typically.
Yeah, absolutely. No, that makes sense because, like you said too, I mean, you'll be chatting about the anatomy and stuff, and you want the sculpt to represent the character, the concept, the IP as best as possible. Very, very one-to-one process.
Yeah, exactly. And like, we run into different design challenges based on the brand. So if it's like, or at least the line, so if it's like the retro line, that retro card back figures I was talking about, it's a little easier because you have a direct one-for-one reference to pull from, which is, that old cartoon, those old O-ring figures. But then on these classified figures, we might mock something up and it just doesn't read. It's not reading. So it's like, let's change it up. Let's change up the shape language. Let's push it, what have you. And that iterative process can take a while.
Nice, nice. And then don't worry, we're getting plenty of questions, so we
Yeah,
can keep you
nice.
busy. What are the processes? What's the process you factor into tolerances between the pieces, or more specifically, what tolerances do you really keep an eye on?
So we keep an eye on all the tolerances. Basically, anytime that a part connects with another part, um, we're considering tolerance. Um, in the sculpt phase, so in this phase of like cutting all of this articulation, typically we're going to move on to a 3D print as well. So a lot of our tolerances are based off of a resin print for just prototyping and testing, and that offset is ideally about 0.12 to 0.16 millimeter wall thickness, which is very subtle. Um, One way you can quickly kind of do that and visualize that is like, let's say I took all of my articulation here and I know all these parts are plugging in. I can say, just throw a Dynamesh on it. All right. So I'll Dynamesh it, and then I'll just like, typically if I'm creating offsets, I'll just run like a subtle inflate, which is under the deformer. You hold control over the button. I'm always holding that control button over these because I have this custom UI.
Yeah.
So I'm like, where is that at again? It's under tool deformation inflate. So, and then I'll just inflate it a little bit. I should actually probably make a duplicate with the history rolled back. There we go. And then with both of those turned on, I can use transparency to kind of see that offset, which I can then measure. And so right now it's at 0.2, which if you look up in the top left hand corner, whenever you use the transpose line, so I'll click on a surface right here and I'll hold shift to drag out perpendicular to your camera view. And I'll just kind of eyeball it, center line there. So that's 0.22. So that's actually a little bit too much. So I would roll that back a bit until I got closer to 0.12 to 0.16 millimeters. And then I would typically just kind of Dynamesh that at a lower resolution, maybe run a smooth on it, just to kind of smooth out some of those nasty parts. And then I could actually use that as a Boolean for my offsets.
Wow, nice.
Now kind of seeing that cut in at that 0.12 to 0.16 offset. You're also seeing that
Super
overlap a little bit right there.
nice. No, that's super cool. That's super cool. Another question that came in too is if somebody creates a portfolio trying to get into toys, should they include images of their 3D prints as to showcase that they can manufacture something from ZBrush to the real world?
Yeah, absolutely. Always, yeah. I mean, we're always looking for like high quality sculpts first and foremost, but after that point to kind of stand out, it is showcasing if you have something tangible that you've actually taken into some level of physical production, whether that be 3D printing, what have you, that's always super valuable to show because that shows familiarity with the process. It shows a familiarity somewhat with like engineering parts to fit and work together. And articulation is an even added bonus if you go in and actually cut in joints. A little tip you can do like for action figures, and then I'll sometimes do for prototyping is like on these joints in the center of that pivot, you'll see kind of a hole here that I have. That's for injection molding. That's for the plastic to actually go through, and it solidifies, which allows it to naturally capture that joint. But we'll even put it in there for our print samples because I'll take that as a Boolean and I'll extend it out to come out the actual forearms or wherever that joint is. And then I'll actually use like a hand drill or something when we 3D print those, and you can put like we'll do it to the point of it's the same diameter of a like a styrene rod. I'll sometimes use like toothpicks, things like that, and I'll just punch it in there, clip off the ends, and then you can actually like test your articulation joint on a physical product and play around with it and see if it works. So that's also a great thing to add if you want to start pinning figures and testing that out.
Oh yeah, that's super fun. More questions? We're good. We're doing good. How do you keep everything in scale for the required measurements throughout the process of creating the figure, or do you worry about scale after?
Ideally, you're going to focus on scale from the very get-go. You're going to create, typically what I'll do, start with like a buck. I'll start with something kind of like primitive, say Polymesh 3D. And so I'll go into like Z plugin under Scale Master, and then I'll leverage this to be able to get my initial scale of the scene. I actually like to take this, and I like to set this with that initial buck to 20 millimeters. I'll tell you why in a second. So if I hit that and I make it 20 millimeters, you'll now see the XYZ size of this scene is 20. That's kind of like ZBrush is like arbitrary internal scale in relation to real world. And this scale also influences all of the other sliders I've found. So like all of your deformers, your Dynamesh, that resolution. And so the reason I set it to 20 millimeters is so that I can then unify the scene back to a scale of 2 at a real world scale of 20 millimeters. And what that gives me, at least in the 6-inch scale, is it gives me a little bit more reliability when I use my Dynamesh slider down here, that I know if I was to crank this up to 4K, I'm going to have this object, which is at 20 millimeters, have a higher resolution in the millions, which is what I want. Or if I crank it all the way down to 8 and hit it, I'm going to get a really low resolution. And so it just makes it a little more predictable. I know that we have this new like button that you can click, but I still kind of prefer to know what I'm going to get out of what I'm doing. So, but on that, now that it's kind of unified to that, you can go back in here and say, we'll switch over to inches. Oh, crash, guys.
Oh, it's okay. You're demoing. It happens.
Yeah.
But yeah, no,
happens
you're
in
right.
life.
Yeah. No, but you're right. Yeah, absolutely. The scale will definitely influence. That's something we talk about too with Dynamesh. The resolution sliders it's an arbitrary number. It doesn't really matter. It's the scale of the object itself or the scene that you're working with. So, to your point, that makes sense that you would want to set that to something that's definitely reasonable, something you can work with. And yeah, we have 100 different ways to do the same thing. So whatever works for you is perfect.
Yep. I always love to have like that controlled environment. I originally I play around a little bit with like the Z scripting, and so was trying to kind of create like bugs that you could script out to where I could create like a startup Z tool very quickly through scripting and creating the little buttons that will like create kind of leverages somewhat the logic behind like Z scale. And it's very difficult to get like Dynamesh and those tools to work correctly if you didn't create sort of that controlled environment by unifying everything to a set value to where everything kind of, it had a predictable result essentially.
Nice, nice. Well, we'll definitely have to also, if you didn't know too, we just added Python, which now has the Z script body. Basically, you can code in Python instead of having to learn a whole new language. So be curious to see what kind of tools you'll develop with that as well.
Super excited about the Python. I can't wait to dig in.
All right, awesome. All right, we got ZBrush back too, and yep, chat still loving the show, which is good.
Yep, a lot of questions pouring in.
Back to
Awesome.
G.I. Joe.
There's like a whole conversation going on in the chat. It's good to see. It's good to see like that. A lot of
Oh,
people
yeah.
interested in toys and collectibles.
We'll actually switch over to Python. It's all relative. So back to the scale aspect. After I've kind of unified the scene, I will typically just we'll actually do it real quick. Really, again, plug in Scale Master, docket.
We have an interesting question while you're prepping this too. Just going to ask it. What's the most significant change in ZBrush over the last couple of years that might have improved your workflow, or a new feature where you're like, yeah, that was really cool?
Introduction of live boolean was big, especially for toys. I would say the most recent one. I really like the cloth brushes now. I've always like sculpted them by hand, and there's still a decent amount of that. Like at least getting into those like idealized folds, especially for like action figures. You know, you want like tension folds in certain places around articulation joints and things like that. But the cloth brush is implemented is sweet because now I can go in with like a dynamic nudge and just like slightly pull to create a little bit of asymmetry in those folds very quickly. You know, being able to push and pull and squash some of those hand sculpted folds to be a little more natural looking. Yeah, and then of course the knife brush. I love the knife brush. Be able to chop parts off and having that clean polygroups. So I'm going to stay away from trying to hit that the inches right after doing that unify because it seemed like it was maybe
Yeah, it was
crashing in.
wasn't liking that with the stream. Yeah, no worries,
Yeah.
no worries. We'll, yeah.
But what you can do, go ahead.
No, I was just gonna jump in with another question. Just follow. Go ahead. Finish your thought.
I was going to say that if you go in there, switch it to inches, and then you just type in 6 inches or whatever scale you want your thing to be, you can click a new subtool at the scale or whatever button. It's in there, and it basically create a primitive shape that's at that scale that you're working with, and then you can kind of use that as a ruler as you're developing your sculpt. If you do finish like a full sculpt of like say a high poly model figure, you can also just go into Scale Master and change that entire figure to 6 inches pretty easily with that tool as well. It's not something to play around with because it's, you know, whatever your current tool is selected, it's going to scale that to whatever is input as the measurement. And then if you have things like if you have all turned on, it's going to then scale everything in your scene as well relative to that pre-scaled object.
Nice. Okay, cool.
So the question was, other than anatomy, what would you say is the most useful thing to learn when designing figures and toys?
I think it's all of those topics, you know, in sculpting are valuable. Anatomy is one aspect of it. Accurate drapery, how cloth folds, different material thicknesses. You know, learning that leather is going to have larger, softer folds. It's going to behave differently than say silk, which is going to have a lot of tighter, thin folds. It's kind of the anatomy of cloth. I would learn hard surface stuff like you know even the last presentation was a good example of that, of just like the variation in your hard surface design, having you know edge profiles that have varying levels of bevel included and varying levels of hardness and softness, and not everything's just 90-degree cuts, or not everything's the same uniform bevel on everything. That helps everything read better. I would master those, just the fundamentals of sculpting. And then I would start to, play with like some engineering, cut things apart. Um, if you have the access or the ability to 3D print, that's always valuable, to be able to then test things. Um, yeah, I would say that the sculpting part, at least for me, was the part that takes the longest to master, and then the learning, the engineering, the manufacturing.
Yep.
It's something you can just add on top, kind of like you would in games. So it's like learning topology and, those more technical processes involved.
Okay. Cool. Thank you.
Yeah, so here I have two different versions of Python in here. So this is kind of the final sculpt file of this figure. You can kind of see what we also have to deal with is design for manufacturing. So areas you'll see, like in the inside here, we have a cut in the hole. But then we also have like these teeth. And typically, like in toys, what we'll do is any part that's not draftable, so it's typically from like a certain angle, or you can pull some sort of slide to be able to capture that detail. If it's overly complicated, where there's a lot of overlapping parts that interfere with draft, we'll typically like cut those parts out, and then we'll try to find another way to like key them together and glue them. Or we'll be worried about like wall thicknesses. Like a lot of these points are too pointy. They would create a lot of like material thickness issues. Typically, like a general rule of thumb is like 1 millimeter is kind of the golden standard of how thick your walls should be for when we 3D print something and manufacture it. We've pushed it down as far as like 0.08 millimeters, but this like right now is hitting 0.35 or 0.4 millimeters. And so when that actually prints or that's manufactured, it's gonna break, or it's not even going to come out at all. And so an example of what ends up happening during the manufacturing phase is that we'll actually go in and start to kind of radius some of this stuff off, which at that scale, it doesn't look as great in the sculpt, but at the actual product scale, you couldn't tell a difference. Same thing with like the earrings. And then also, let's see here. Let's see if I can auto group it. Yeah. We actually like split out the tongue, and then we have that piece plug into the back of the head. And so that way you can also capture those teeth, because your draft angle is front to back here, which another tip if you want to like test your draft angle. I used to use this a lot, not so much ever since the introduction of the draft analysis, but like polygroup front was one I used a lot, which would basically take like your whatever direction your camera was moving, or you can change the angle of it and then get kind of an idea of where that draft line was going to be. You can kind of see right there, that's where that draft line would be, right across the center there.
Very cool. Wow. Yeah. It's all those little tricks and little nuggets that kind of help bring it all together,
Yeah, absolutely.
Yeah. We had a question about just the jobs in general. Would you say there's actually a good amount of jobs in the toy industry, or do you think the toy industry is kind of a niche field?
I think there's a decent chunk still. I think a lot of the work in the toy industry, it may be different at other companies, but at Hasbro specifically, we're a very small team. So there's only like 6 3D dev leads, and we're each heading a different brand. And so a lot of work that would come out of like our department would be like vendor freelance work. And so if we were to send things out, it'd be to vendors and freelancing, which is a lucrative opportunity. At other companies, I don't know if they have like more internal art staff that are all developing internally, but at least for Hasbro specifically, yeah, freelancers are major force that
Nice,
we love
nice.
to leverage.
Someone was asking, how do you use the draft analysis? Can you show that real quick?
Yeah.
Like the new draft analysis tool.
You guys might have to help me find it because I haven't used it in a minute. I thought it was under render.
No, it should be under the transform menu.
It's transform.
Right
If I
here.
remember correctly. Yeah.
Transform. All right. So you can basically set this on, which shows your draft analysis. You can change the actual angle. So typically we're working at a 3-degree angle for toys to pull out a mold. So I will typically set it to 3. That, and then you can also set your direction. So you can sit there and look at something with your camera. Say I want to draft it from this angle, or try to. You can set that direction, and then now it'll readjust. Or I can set it from this angle, and it'll show you the draft analysis. And then basically that yellow portion right there, this is decimated, so the topology is kind of whacked out, but basically that center yellow line right there is telling you what your draft line is currently within that 3-degree tolerance. And then the red and the yellow is obviously your front or your back side of whatever mold or draft you're going to be pulling.
Nice, nice. The one you might have been thinking of too, because you were under render, was the live Boolean option of showing the coplanars or showing issues, which you could use with live Booleans. Have you used that tool before?
I have not.
Oh, okay, cool. Yeah, it's just under render Booleans at the top. So if you had live Boolean turned on, any parts that are like kind of airing out or showcasing, yeah, if you click that one, that usually will showcase like any type of like issues, thin walls or something like that. So that might have been the other one you were thinking of. It's a pretty cool tool.
Yeah, I'll have to play around with it after this. It might be the new go-to.
Yeah.
There's Paul. G.I. Joe.
Wild Paul appears.
There
What's
it
up,
is.
Paul?
What's up, Matt?
Welcome to the show.
Thanks for having me.
Yeah, of course.
Hi, Paul. Thanks for accepting
Hi.
our invitation.
Yeah. better to be here, be late than not here at all.
Yeah,
Absolutely.
exactly.
Just showing some general draft tips.
Yeah. Very nice.
Yeah. Let's
So
see here.
I can switch back to the
Alright.
G.I. Joe anatomy really quick. I meant to show this as well. Just kind of on these accessories. One of the aspects that we like to build in, like I was saying about playability, toyetic nature of these, is just having parts that kind of plug into one another, like being able to kit out your own weapon at the 6-inch or the 6-inch scale. And so we'll have like portholes actually built into, like, say, the end of a silencer or something, also at the end of the barrel. So that's the same standardized port for both sides, so that you can kind of like daisy chain pieces together. And so on the end of that, we would put like sculpted fire or like a flare effect, or a projectile, trail type FX sculpt that you can plug in. The same thing with like the silencer. And then we have like a mag, that'll actually be plugged in.
What are the tolerances you usually give everybody for these, Matt? For thickness tolerances, and especially because you're dealing with a toy where a kid's going to be playing with it, right? So what do you usually set for your tolerance, and what things do you look out for?
So typically we're still aiming for that like 1 millimeter ideal wall thickness around, well, typically your walls. But then we were saying that basically the offset, if you're going to like 3D print this or test it out between actual parts, it's that 0.12 to 0.16 millimeter offset.
Yeah, absolutely. Cool. Okay, so
My
just-
GI Joe didn't have this much articulation. It's not fair.
Just going to do a quick time check here. We got about 15 minutes and stuff.
Okay.
I'm kind of curious. There are some questions in the chat still too, but I know at the beginning of this, I had mentioned if you might be willing to do like a articulation tips tricks demo, something not
Yeah.
too complicated. I know it takes time. Do you mind going through a quick demo of how you approach articulation?
Yeah, for sure. Let me load up this tool here. It's kind of
Sweet.
big, so it might take a second. But
That is okay. Cool. We have another question too while that's loading. What are the things you need to tinker with when you receive a scan of a prototype sculpture, if it was made in clay, before you change it? Do you guys do any type of photogrammetry?
we do not on GI Joe. On other brands, we will. So like Marvel or Star Wars, sometimes you might receive like scan data from the studio of like an actor or an actress. If you're working with that, typically it's kind of low resolution, so you're going to end up, doing the typical like scan cleanup of cutting off those stray parts, cleaning up, smoothing the surface out, and then kind of resculpting and refining the portraiture. Typically, is what we're using it for. On GI Joe, we don't have any of that. We're just sculpting everything because these are fictional characters. Might be
Nice.
cool to get a couple weapons and then scan them and pull them in, but the manual sculpting of guns has worked out fine.
Nice, awesome. All right, yeah, yeah. Demo seems to be a high thing, so I'll let you cook.
All right. So yeah, I have sci-fi here. So this is kind of an early iteration of sci-fi. This is just before articulation is being cut in. So I can kind of show sort of what I meant earlier about that whole Boolean structure. It gets pretty lengthy where we're going in there and cutting all these pieces out. But like we could start at say the head. So typically those are made up of like separate subtools. This is all combined, but we'll actually go in there after the fact and I'll start cutting parts out. So like I'll cut out the neck, we'll resculpt things to make it a ball joint. You'll have a ball joint there that you can actually use as a reference to kind of conform it to. Creating these like little joints. It's pretty easy to do, just like these simple primitives. Just a ball with a cylinder. And then this is like an example of chop the head off, following the jaw line, cleaning it up a bit. It's all kind of dirty on the bottom there, but that's just kind of a starting point. And then I'll actually take usually that ball joint. So like say I was to duplicate this. This is where I really like that knife tool. Go in there and actually start cutting articulation. So I'll sit there and I'll find kind of my center line. I'll first position the joint where I want it, which is typically like on a head. I'm going to position it towards the top of the cranium, towards forward, towards the front of the forehead, which is where it's currently sitting. And then I'll go in there, and then at about I'd say about the 60 to 70% point on the hemisphere of the ball, with your 50% being right down the middle. I will go a little below that because you want a little bit of that bite, a little bit of that overlap, so that you can pop that joint on and not have it just fly off the figure. We'll take a chop, which gives me a clean polygroup on the bottom, which I can then isolate, mask, snap my gizmo to the bottom of it. Then I can just use that control modifier to start pulling it out. And then I'll start, pulling it out, start flaring it out. I can actually turn off some of this stuff so you can see what's happening. So now from that, I have a pretty pretty basic like primitive here that I can play with. May go in and add a bevel to kind of soften some of these out, or even sometimes I'll go in and like crease, apply a crease and then just probably subdivisions to smooth all this out. But for the sake of this, we'll just add a bevel. We'll actually keep it kind of dirty. Why not? It's just, you can just use that as a negative. We'll pull that down under the hierarchy of the head. And now you can kind of see that cut. Let's turn all this off. See kind of that cut in there. And then I may, with this actually turned on, I'll typically like grab my move tool, turn on that symmetry and start to like kind of massage it kind of into place, those verts into place, pull them in a bit, start to get a little bit cleaner of an edge. Because like we were saying before, you have those wall thickness concerns that we now need to consider. So that 1 millimeter of wall thickness, starting to pull it in.
And just to be clear too, you're messing with the actual the joint
Yes.
itself, the negative. You're not messing with the head.
Exactly. Yep.
Cool. Yeah.
And then that's another aspect that kind of I've learned through trial and error is that no matter how complex your Boolean hierarchy is, there's always going to be a little bit of cleanup typically at the end once you pull that trigger on that Boolean for toys. So at the end of the day, like if I pull that trigger on that, we just went into the gear and hit Boolean with subdivision. It should pop it out right below it. If it doesn't, which it did, so never mind, won't have to worry about that. But I'll typically take that tool, maybe throw a Dynamesh on it. And then actually get in there and start cleaning up some of this stuff with like smooth. If I go around the edges here, start smoothing some of this stuff out, it's going to get rid of some of the surface detail, which I'll have to go back and like, put a spray on with like a fine tip alpha, and I'll spray, some of those sculptural details back on there. But I'm starting to like clean up stuff. One thing I really like for specifically toys is we're always going around and like thickening walls and stuff, just like little minute thick like areas of added thickness. So I really like the move tool and then turning on back face mask. And then with that, I can actually go in, find an angle, and then perpendicular to that, I can kind of start to pull a little bit of that material out. Should turn on symmetry.
Now, when you were talking about like some of the back of the detail itself is kind of faded away a little bit, do you use project history and kind of bring that info back, or like a morph target?
Yeah, sometimes it depends on like if it's just fast enough for me to like quickly throw, like this, for example, is just a spray operation with a fine detailed alpha. I'll probably just do that. But there are times when, I'll cut something and then it's like a really intricate hard surface detail that I'll actually go back, pull that old subtool and like project that detail on it. Sometimes with articulation, that's really the only way you can do it with articulation, because once I've committed to that Boolean, projecting the history on it, it's going to like try to project onto geometry that's no longer there. And so that sometimes creates issues, and so, I'll just go back in and like start cleaning up things, but this is usually just like damn standard with backface on.
Nice. Wow, that's looking really cool. That's awesome. Just like that. Cut a joint. I love it.
Cut a joint.
That's so cool. Well, just a real quick time check. We got about 5-6 minutes ish left. Time for any last questions that are coming through. Make sure to throw them in the chat. Let me just make sure we didn't miss anything? Oh, here you go. Here's
There
one.
was
Do you ever
there,
add relief
Yep.
cuts to allow the bullion to snap in easier? Or is that 60-70% that you were talking about kind of help with that?
You talking about relief cuts as in like
For that ball joint for the head? Like, do you factor in relief cuts, or is that just kind of take care of itself with the way you built it?
yeah, that typically it'll take care of itself. And then a lot of it, it's like a lot of time we're moving so fast that I'm chopping, bullions out really quick, and then kind of a little bit of this re-cleanup sculpting that occurs right afterwards. And ideally, it's like build the bullion to the point where the cleanup is minimal. But like I was saying, like we don't often. It usually takes more time to build a bullion that is the second you hit like execute this bullion, it just comes out perfect. There's no touching, you don't have to touch it any further. That usually will take a lot longer than just quickly chopping it out and cleaning it up after the fact. Um, and then we
Yeah.
also, like I was saying before, it's like we have design changes and stuff that go on for like 2 or 3 weeks. And so it's like I might be working on a part that's we've already cut, already, printed and tested. And so like going back into that Boolean structure and having to like finagle with the Booleans again to get this new design change implemented, it's usually easier to just work from that cut piece than it is to like finesse your old Booleans.
Nice. Yeah, makes total sense. For the sculptural details, another question that came in is how do you know how much depth to give the detail for it to read once it's gone through manufacturing?
Yeah, so it's there's a standard. There's like an ideal depth. A lot of times I'm eyeballing it. Like I've done enough of them at this point to know like what's going to read well. But I would say like in general, you're looking for around like a 1.16, similar to like your offset to like a 0.2 millimeter in actual depth of a texture. Um, so something like this, it's just like a generic weave that we're cutting in there, but it's pretty aggressive. We also have that like stored on layers so that if I need to punch something up for production, it's like I can just be duplicating that. It also has a morph target so that I can go back in and morph out details where I need to. So that non-destructive workflow is ideal for textures, especially.
Yeah. No, it makes sense. This is also too where I would recommend anybody who's even curious in getting into toys, just get into 3D printing, print out your stuff, and see how soft something actually is when you think it's like cut in,
Yeah.
and then you'd be like, oh, I should actually push that.
Yep, absolutely. It's one of those things too where it's like we're designing it out and it's the economy of detail. It's that only certain details are really going to show up anyway. So it's like when we get to that tertiary step, a lot of the times we're blowing out those details. Sculpturally, it looks blown out, but then when it comes out in production, it's softened. The plastics, softened out, and those textures are more subtle. So we can't really add like all those little. I would love to really go in there and finesse all these hard surface scribe lines and everything everywhere, but at the end of the day, like a lot of that stuff's going to wash out, and so you gotta be intentional with where you're going to put things and how deep, based on what's going to read at the end product.
Right. Yeah, it makes sense.
One last question from that I'm curious as well. Do you have a standardized joints across the product line, or is the articulation for each toy? Is it made for each toy individually?
Yeah, so on GI Joe we have more of a standardization. We're up to like close to 200 figures at this point. So we use standard, so it's something uh, we built from day one. That has changed over time. Like your joints will evolve as the functionality does, and so we might start swapping parts out and then reusing those for future figures. So yeah, like diameters, things like that are pretty standard. A lot of like the butterfly connection points where the they pop in. A lot of that's standard, so that we can kind of rip the arms off of one figure and try it on the torso of another figure. Maybe that would look cool with those arms. You know, those types of things we might kit bash and play around. Things like the, if you can see my screen here, like things like the heads. So like I have that sci-fi figure. This is an early engineering prototype of him. So like that head there, that's a standard joint that I can pop off. I could take somebody like a wetsuit here. I'll take his helmet off, pop his head off. Then I could take, you know, their heads and their standard fits. We can take, you know, wetsuit's head there, pop it onto sci-fi's body. And then there's also like a depth that they sit. You know, we want them to be kind of at least along the same body types. We want them to have similar depths so that when they sit on the neck, they look proportionate in place. The depth of those cuts are different. Than you might have one guy that has like a giraffe neck, the other one looks like a turtle, and that's not ideal either. So yeah, so there's the level of standardization for sure.
Oh, cool. Well, I hate to be the guy who has to say the next sentence, but our time is coming to an end. So, Matt, thank you so much for being here with us, and thank you to Hasbro as well for taking the time to come and answer questions and demoing an articulated piece. Thank you so much. I appreciate that.
Thank you so much, Matt.
Yeah, thanks for having me, guys. It was a blast.
Yep. And thanks, Paul, for showing up.
Hey,
Missed you.
thanks for having me. This was really a blast. I love me some toys, Matt. G.I. Joe,
American hero. Yeah, it's so awesome.
right.
Yeah. Well, as they say, knowing is half the battle, right?
Absolutely.
Heyo.
There we go.
It's my whole childhood. It's my whole childhood. I seem like I'm battling more than knowing.
All right. Well, Matt, we'll let you go. Thank you again. It's been a pleasure. And don't go anywhere, chat. We'll be right back.
All right. See you guys.